So now let's use that very complicated equation. So what's the gravitational force between the Earth and the Moon? So if the Earth has a mass of 6.0 times 10 to the 24th, and the Moon has a mass of 7.4 times 10 to the 22nd, okay, and they are 3.8 times 10 to the 8th meters away. All right, so we have all the numbers we need, it looks like. So let's put this into our equation. We've got Fg equals G m1 m2 over r squared. All right, so Fg equals G is 6.67 times 10 to the negative 11th. M1 is 6.0 times 10 to the 24th. I'm not going to have enough room. And M2 is 7.4 times 10 to the 22nd. So it doesn't matter if you put 7.4 before 6.0. This is just the order that they came in when I had them written down, so this is the order I put them in. So now we have to put our r in here. R is 3.8 times 10 to the 8th squared. Alright, so you see that there's an exponent on the r right here and here. Some of you are like, you might be thinking, well, do I add those two together? Do I multiply the exponents? Don't think anything about doing stuff with the exponents. Just take 3.8 times 10 to the 8th multiplied by itself. So do 3.8 times 10 to the 8th multiplied by 3.8 times 10 to the 8th, or just square it. We're not combining exponents. So now, this is a tricky thing to put in the calculator. I would write it in your calculator exactly as you have it written down, doing parentheses around everything. Because if you don't, then something could go awry and not work out correctly. Whereas if you add all of the parentheses and everything, then you are sure that everything is working out and nothing is going funky. Alright, so what we're going to do is we are going to do the top half and the bottom half first. We're going to multiply all the numbers on the top half together and write that down. And you should get 2.96 times 10 to the 37th. And then, now we're going to take 3.8 times 10 to the 8th squared. And you should get something along the lines of 1.44 times 10 to the 17th. Alright, now, using parentheses around basically everything, take 2.96 times 10 to the 37th divided by 1.44 times 10 to the 17th. And you should come up with a number of 2.06 times 10 to the 20th newtons. So, as you can see in this problem, these numbers are really, really big. Don't try switching them to standard notation before you do calculations, because that is creating a lot of work for yourself. Always just put all numbers in parentheses, and that will make your life a lot easier. Also, do the top half and the bottom half first before you do the dividing, because that will also make your life a lot easier. So now, what if the distance between the Earth and the Moon doubled? So what if it wasn't 3.8 times 10 to the 8th, but it was 7.6 times 10 to the 8th. All right, so you're going to have the same mass for Earth, the same mass for the moon, and G is the same. We just have a different distance. So let's write that in here. Fg equals 6.67 times 10 to the negative 11th, parentheses around that. The mass of the Earth is 6.0 times 10 to the 24th, and the mass of the moon is 7.4 times 10 to the 22nd. All right, and then your R is 7.6 times 10 to the 8th squared. All right, so just like the last one, we're going to do the top half and then the bottom half. Well, we already know the answer for the top, so it's 2.96 times 10 to the 37th. So now let's take 7.6 times 10 to the 8th squared, and you should get something like 5.776 times 10 to the 17th. Now take those two numbers divided by each other. 2.96 times 10 to the 37th divided by 5.77, 6 times 10 to the 17th, and you should get something like Fg is equal to 5.12 times 10 to the 19th newtons. All right. So now what if it was tripled? So let's take 3.8 times 10 to the 8th times 3. And our distance number is going to be 1.14 times 10 to the 9th. All right, all other numbers are the same. So again, put it in the equation just like normal. 6.67 times 10 to the negative 11th. 6.0 times 10 to the 24th. 7.4 times 10 to the 22nd. Over, now using our distance we've calculated here, 1.14 times 10 to the 9th and squared. All right, so now let's do our little cheater. Do the top first. Well, we already know the answer to that because the numbers haven't changed. So 2.96 times 10 to the 37th over, plug 1.14 times 10 to the 9th squared into your calculator. And you should get 1.30 times 10 to the 18th with some rounding. And plug those two numbers into your calculator. You should get an answer of Fg equals 2.28 times 10 to the 19th newtons. The numbers are slowly starting to get smaller. If you see that our first number was to the 20th power, our second number was to the 19th power, but it was at 5. Our third number is to the 19th power, but it starts with a 2. Well, now what would happen if we quadrupled the distance? We would come up with a number for our distance of 1.23 times 10 to the 9th. All right, I'm going to cheat just a little bit. I'm going to write our already calculated number here. So if you square your distance, you should get a number of 1.51 times 10 to the 18th. Then if you plug those numbers into your calculator, you should get an answer of 1.96 times 10 to the 19th newtons. So, as you can see, the further in distance you went, the less the force became. So, distance is inversely proportional to gravity, as we said. The larger the distance, the smaller the gravity. And so if I would have said what would happen to the force if the distance between the Earth and Moon halved, so if it got closer, then obviously we would know that the force number would then increase because the distance is getting smaller. All right, so let's just do a little bit of recap here. So Newton's idea of gravity was that it was universal. It happened everywhere and anywhere. We also know that weight is different than mass, and that weight is mass with gravity. We know that the equation for the law of universal gravitation is Fg equals g times m1 times m2 over r squared. And we know that the universal constant, which is g, is 6.67 times 10 to the negative 11th. And we know how to calculate all of this fun stuff. So this wraps up the end of this lesson. If you have any questions, write them down in your journals or send me an email or text message if you feel that it needs to be answered fairly quickly. Otherwise, have a great day.